Hello again everyone, welcome back to ptet.chemistry channel. My name is Dr. Ant. In this tutorial video, I go through this work 2. This is for the combined science, which is basically the 3 pure science combined into one subject. And as such, the contents are a bit more diluted. Even though this is for the Cambridge International O Level, the contents within are suitable for any 14 to 16 years old combined science curriculum all around the world. This work too is based on the acid, bases, and salts topic, which is part of the contents covered within the syllabus, the curriculum. In this first question, so we have a pH meter. This is a digital pH meter, so it works with a sensor. So this is a electrode with a sensor that is dipped into the solution, which in this case is pure water. This is sodium hydroxide solution. This is dilute sulfuric acid. Sodium hydroxide contains Na plus OH minus. Hydroxide means you contain the OH minus ion. And that is what make it the pH greater than 7. That is what make it a base or alkaline. Whereas you have this thing called sulfuric acid. If you have acid, you have H plus ion. Of course, the formula for sulfuric acid is H2SO4, giving you 2 of the H plus and 1 of the SO4, 2 minus from year 9 chemical formula. Acid contain H plus ion. This is called hydrogen ion, and the pH as a result of these acidic solutions is lesser than 7. That is what you call an acid. Pure water, on the other hand, you call that pH 7. This is H2O. From dot and cross, we know that oxygen with 6 electrons in the outer shell and hydrogen with 1 electron in the outer shell. Oxygen want to share 1 and 2 electrons with hydrogen. Of course, hydrogen just have 2 electrons to share on each hydrogen. So now, if we say cross belongs to the 6 electron in the outer shell, if we use 2 already, you are left with, 4 more. So this is water. That is the formulation for water. Dot and cross, this is just showing the covalent bond because you're sharing the electrons in between nonmetal. As well as nonmetal, you have 2 covalent bonds. This is 1 covalent bond. This is another covalent bond there. So complete the table below by suggesting suitable pH values. So this is a factual kind of question. So pure water, there is your neutral pH. This is pH 7. Sodium hydroxide is going to be fairly high. This is very strong base, and therefore the value is going to be fairly high, very close to 14. Or you can say 13 should be alright as well. And then as for the acid, it's going to be fairly low. This is a very strong acid, so it's going to be very close to the bottom scale, so 1 or 2 would be alright. In general, you have a pH scale which ranges from 1 to 14. Just for simplicity, we'll just call it 1 to 14. And then here you have very strong acid, here you have very strong base or alkaline, and then pH 7 is your neutral point, neutral pH there. Suggest one advantage. Advantage means what is good about it, what is the good point of using a digital pH meter rather than a piece of litmus paper. So we know that in acid, your blue litmus, the blue litmus will turn red. And of course, in base or alkali, just like the test for ammonia gas NH3 is an alkaline gas, is a base. So what happened with red litmus is red litmus paper, which is moistened a little bit, a moist or damp red litmus paper will turn blue. Now the biggest problem, the biggest issue with litmus paper is blue turns red or blue remains blue, or red turns blue or red remains red. It doesn't really tell you when you reach neutral or not. So when you compare the acidity of 2 different acid solutions, both of them are acid. Since both are acidic, both solutions, the question says how are you going to compare both solutions which contain acid? Since both solutions are acidic, both have pH lesser than 7 or lower than 7, and as a result, in both cases, in the 2 cases, the blue litmus will turn red. And it doesn't tell you which one is stronger, which one is weaker. It doesn't tell you the pH value. The blue litmus will just turn red because both of them contain acid, both of them contain H+. So that is not going to be a very good indicator in that sense. Whereas a pH meter, so what is the advantage then? A pH meter would be more accurate in determining, I think I spelled it incorrectly, in determining or giving the pH values. Part C, when a reactive metal is added to an acid. So this is a reaction between an acid plus a reactive metal. Acid reacts with metal and you will get something called a metal salt. This is a general name, metal salt. The nature of the salt depends on the acid you use. The nature of the metal depends on what metal you use. And you also produce a gas called hydrogen gas. Hydrogen gas formulation is H2. As you know about dot and cross diagram, they want to share one electrons with another hydrogen atom. This is called diatomic molecule. From year 9 chemical formulation, diatomic means two atoms. Di refers to two, diatomic refers to two atoms. They are bonded together. They are bonded together by covalent bonds. And they form a molecule there. So covalent bonds involve the sharing of electrons between nonmetals and nonmetals. So name one reactive metal. Name, you gotta give the name, must not be added. So very reactive metal, very dangerous. So therefore we can think about sodium, you can think about potassium. So these are extremely reactive metals, and then they are not supposed to be added to acid straight away because this is a very reactive metal. So if it is very reactive metal, it reacts violently. So it gives you a violent reaction, or vigorously, a very vigorous reaction, very dangerous. And this is with acid. Okay, this is reacts very violently or vigorously with acid, and therefore very dangerous reaction overall. So this reaction between magnesium and acid, magnesium is less reactive than sodium or potassium, and therefore when you react with dilute hydrochloric acid, you will get a fairly safe reaction, magnesium chloride. So magnesium is the metal plus HCl, which is hydrochloric acid. You are going to get magnesium chloride, which is the name of the salt. Chloride because it started from hydrochloric acid. You also get hydrogen gas. Hydrogen gas, of course, exists as H2 gas. And you use a burning splint. A burning splint is the one where the flame is still going on. You also call this a lighted splint. The other name for burning splint is just a lighted splint. State and explain what the student observe. Observe means what do you see? So what we see is that the lighted, or you can say the burning splint burns with a pop sound, or it produces a pop sound. This is characteristic of hydrogen gas being produced. They are asking you for an explanation. So that means hydrogen gas is produced, hydrogen gas is present. That is the explanation. The next we have these questions. Halogens are reactive elements found in group 7 of the periodic table. By right, this group 7 should be VII as stated in your periodic table in the Roman numerals. Halogens refer to those fluorine, chlorine, bromine, iodine. These all exist as diatomic molecules, which of course you will learn more about them in the periodic table under group 7 chemistry. However, you have learned the dot and cross in year 9 chemical formulas, where you share one electrons. Since all the group 7s have 7 valence electrons, 7 electrons in the outer shell. They just need to share one more electrons with their neighboring atom of itself to complete the outer shell. Alkali metals refer to the group 1 metals, and etc. etc. So alkali metals react with water. So this is referring to the group 1 metals such as lithium, sodium, potassium, and so on, etc. etc. So what you get is when you have metal plus water. This is also in year 9 chemical equation. Year 9 chemical equations. You can obviously, go back to the topical playlist in year 9 chemical equations. It's part of the combined science syllabus. what you get is a metal hydroxide. The hydroxide itself contains OH minus ion, and this pH is greater than 7. It is a base or an alkali. Now name the gas. They want the name, not the formula. Okay, they want the name, not the formula. That's the first thing. They want you to describe a test for this gas. So describe a test means what do you test it with and what is the final result. So the name of the gas is what you call hydrogen gas, and you use a burning or a lighted splint, whichever one you want. Both of them mean the same thing. The fire is still going on. So what is the result? You must specify the result. The burning or the lighted splint, it burns with a pop sound. The pop sound is characteristic of hydrogen gas being present, which of course it is present here. It's 3 marks because identity of the gas, what is the test, what is the result of the test there. On to the last bit in this work, describe. So you have got to use a lot more words. There are a lot of lines for 3 marks. You may draw a diagram. But you don't have to. This is between potassium and also bromine atoms. So we started from bromine, which is a group 7 element. So a group 7 element will have 7 outer shell electrons. That means 7 valence electrons. And potassium being a group 1 metal. And then you have 1 valence electron or 1 electrons in the outer shell. It means the same thing as outer shell electrons. So the group 7 element is also known as a nonmetal. Of course, there are nonmetal halogens. There's a special name given for group 7 elements. Group 1 is what you call the alkali metals. Special name given for group 1 metals. So in the end, what happened is the potassium would, now have full outer shell, because you already lost the 1 electrons in the outer shell. So potassium atom, so if I say potassium atom has 1 outer shell electrons. And then what can I say about bromine? Bromine is a group 7 element, group VII. The atom has 7 valence electrons or 7 outer shell electrons. Then what happens is between a metal and a non-metal, you're going to get a transfer of electrons. So potassium atom, it has 1 outer shell electrons. It loses 1 outer shell electrons. That is 1 valence electron, VALENCE, to become potassium ions, which is K plus ions. On the other hand, bromine atom with 7 outer shell electrons ready, just gains 1 valence electrons to become Br minus ions. If I draw a diagram, the Br, I have to use a different representation because I've already used crosses for the potassium. I started with 7 dots because 7 outer shell electrons, because group 7 element halogen. And of course, I have 1 of the cross because I transferred the electrons from the metal, lost the electron, moved to the non-metal. Non-metal gain 1 electrons because you already have 7 in the group 7. 7 outer shell electrons, you gain 1 electrons, you have a -1 charge. Between the positive ion and the negative ions, what kind of bond do you form? So therefore, K plus and Br minus form ionic bond. Ionic bond is basically formed as a result of transfer of electrons from your metal to your non-metal, because your metal lose electrons, your non-metal gain electrons. You form ionic bond between positive ions and negative ion there, and that is the overall 3 marks there. So that's it really for this tutorial video. So this is work 2 for the acid, bases and salt topic for the combined science 5129 curriculum or any other 14 to 16 years old similar curriculum all around the world. Thank you for watching. Don't forget to click the button on the bottom right to subscribe to my channel. Follow me at ptet.chemistry. That's at ptet.chemistry on Instagram, Facebook, Twitter and Telegram to get connected. Thank you for watching, and I'll see you in the next tutorial video.